Imagine forgetting how to drive, imagine forgetting your loved one's face, imagine losing yourself piece by piece. Today, we explore Alzheimer's disease, a disease of the labyrinth of the mind where memories fade into oblivion. This enigma of neuroscience, a disorder of the brain, is steeped in complexity. It's an intricate web of tangled neurons where the very fabric of our identity is slowly, yet relentlessly, eroded away. The pathology of Alzheimer's is a daunting puzzle, a conundrum that has baffled the brightest minds in medicine for over a century. Despite numerous scientific advances, the disease continues to cloak itself in a shroud of mystery. Our understanding of it remains fragmented, like the disjointed memories of those it afflicts. The relentless pursuit of knowledge pushes us further into the labyrinth, illuminating dark corners yet revealing more unanswered questions. We are explorers, navigating a vast neural wilderness, pushing the boundaries of our scientific comprehension. The enigma of Alzheimer's continues to captivate and challenge us, fueling a relentless pursuit of understanding. A voyage through the neural fog that is Alzheimer's is a journey into the unknown. Unfolding the neurobiological intricacies of Alzheimer's, we delve into a world unseen by the naked eye. In the labyrinth of the human brain, the tale of Alzheimer's unfurls, marked by the insidious formation of beta-amyloid plaques and tau tangles. These structures, far from benign, are the harbingers of a cognitive decline that gradually steals away the essence of self. Beta-amyloid plaques, sticky aggregations of protein fragments, encroach upon the spaces between neurons. They are the rogue elements, disrupting the harmonious communication within the intricate neural network. Their impact is not limited to mere interference. These plaques set the stage for an even more sinister actor: tau proteins. Under normal circumstances, tau proteins play a crucial role in maintaining the structural integrity of neurons. However, in Alzheimer's, they undergo a Jekyll to Hyde transformation. The proteins become hyperphosphorylated, leading to their detachment from the neural cytoskeleton. They aggregate into twisted strands known as tangles, wreaking havoc within the neurons. The interplay between these two pathologies, the extracellular beta-amyloid plaques and the intracellular tau tangles, orchestrates a symphony of neural disruption. The neurons, unable to function efficiently, lose their ability to communicate, triggering a cascade of events leading to their eventual death. This neuronal loss manifests as the cognitive decline and memory impairment characteristic of Alzheimer's. The brain regions most affected are those involved in memory and cognitive functions, such as the hippocampus and the cerebral cortex. As the disease progresses, these regions undergo significant atrophy, further exacerbating the cognitive symptoms. In the neurobiological narrative of Alzheimer's, it is crucial to remember that the disease is not merely a result of these pathologies. Instead, they are part of a complex, multifactorial process that involves genetic, environmental, and lifestyle factors. In the microcosm of the brain, Alzheimer's orchestrates a symphony of neural disruption. It's a haunting melody, one that echoes the urgency of our quest to understand and ultimately conquer this devastating disease. In the genetic blueprint of life, do we find the seeds of Alzheimer's? The search for answers takes us deep into the intricate world of genetics. Every living organism, every human being carries a unique genetic code, a blueprint of life. And within this complex tapestry, we find the threads that tie us to Alzheimer's disease. One such thread is the APOE4 gene, a variant that has been strongly linked to the risk of developing Alzheimer's. A person with one copy of this gene is 2 to 3 times more likely to develop the disease, while 2 copies increase the risk up to 12-fold. Yet it's crucial to remember that APOE4 is a risk factor, not a destiny. It helps shape the landscape of our genetic susceptibility, but it doesn't dictate the course. The role of genetics in Alzheimer's extends beyond APOE4. Other genes like presenilin 1 and 2 and the amyloid precursor protein gene, when mutated, can directly cause the disease. These genetic culprits are rare but potent, leading to what's known as early-onset familial Alzheimer's, a form of the disease that strikes people as young as in their 30s and 40s. As our understanding of genetics deepens, so does our insight into Alzheimer's. We're uncovering new genetic markers, elusive fragments of DNA that may hold the key to early diagnosis and targeted treatments. These markers could illuminate the pathogenesis of Alzheimer's, offering glimpses into the disease's progression long before symptoms arise. Genetic research is also paving the way for personalized medicine in Alzheimer's care. Imagine a future where treatment strategies are tailored to an individual's genetic profile, where we can mitigate the risk and slow the progression of the disease based on one's unique genetic makeup. The role of genetics in Alzheimer's is a vast and complex tapestry, rich with potential for discovery and innovation. It's a journey of exploration, of unraveling the threads of our genetic blueprint to understand, combat, and ultimately conquer this devastating disease. As we delve into the genetic tapestry, we discover that Alzheimer's is not merely a disease of the old, but a disease inscribed in our DNA. Here are a few facts on Alzheimer's. Smelling trouble. While memory loss is a hallmark symptom, a weakened sense of smell can appear much earlier in the disease process, sometimes even a decade before other symptoms. This can be a valuable early warning sign. Early onset surprise. Alzheimer's isn't just a disease of old age. Around 5% of cases are early onset, striking people in their 30s and 40s. This highlights the importance of not dismissing memory issues as simply a normal part of aging. The brain's third type of diabetes? Researchers are finding intriguing links between Alzheimer's and insulin resistance, a precursor to type 2 diabetes. The theory is that the same enzymes that regulate blood sugar may also help clear harmful proteins in the brain, and when they're busy with sugar, they can't do their job for the brain, potentially contributing to Alzheimer's. Brain power protects. Engaging in lifelong learning activities like taking classes, playing musical instruments, or even just doing puzzles may help reduce the risk of developing Alzheimer's. It seems constantly challenging. The brain builds resilience and strengthens cognitive function. More than memory loss, Alzheimer's affects the entire brain, not just memory centers. This can lead to a surprising range of symptoms, including changes in mood, personality, and even sleep patterns. Being aware of these broader effects can help caregivers better understand and support those with the disease. Before we go, let's look at some recent research into Alzheimer's. Herpes simplex virus and amyloid beta accumulation. A study published in Alzheimer's Research and Therapy explored a potential link between the common herpes simplex virus type 1, HSV1, and the buildup of amyloid beta protein in the brain, a hallmark of Alzheimer's disease. The research suggests a possible role of HSV1 in triggering or accelerating the formation of amyloid plaques. While further investigation is needed, this opens a new avenue for exploring potential preventative or therapeutic strategies targeting the virus. Source: Alzheimer's Research and Therapy, April 2024. Human in vivo evidence of associations between herpes simplex virus and cerebral amyloid beta load in normal aging, cathepsin D, and protein accumulation. Published in the same journal, this study investigates the role of cathepsin D, a lysosomal enzyme, in Alzheimer's pathology. Researchers found that deleting this enzyme in mice led to a buildup of both amyloid beta and tau protein, another key player in Alzheimer's. This suggests cathepsin D may play a protective role in clearing these harmful proteins, and future therapies could focus on ways to enhance its function. Source: Alzheimer's Research and Therapy, April 2024. Prominent tauopathy and intracellular B-amyloid accumulation triggered by genetic deletion of cathepsin D, implications for Alzheimer's disease pathogenesis, cerebrospinal fluid biomarkers, and neuropsychiatric symptoms. This research, published in Alzheimer's Research and Therapy, examined the connection between specific biomarkers in cerebrospinal fluid, CSF, and the presence of neuropsychiatric symptoms, NPS, in patients with cognitive decline. The study found associations between different types of CSF abnormalities and distinct NPS clusters. This could pave the way for more personalized treatment approaches based on an individual's specific CSF profile and NPS presentation. Source: Alzheimer's Research and Therapy, April 2024. Cerebrospinal fluid, amyloid B, and cerebral microbleed are associated with distinct neuropsychiatric subsyndromes in cognitively impaired patients. In the quest to conquer Alzheimer's, we stand at the crossroads of discovery and despair. The road to understanding this formidable malady is fraught with challenges and unexpected turns, yet it's a journey we must undertake to unmask the enigma that is Alzheimer's disease. Currently, our voyage is steering us towards the exploration of novel therapeutic targets. We're delving into the realm of neuroimmunology, examining the intricate dance between the brain and the immune system. We're scrutinizing the role of neuroinflammation, hypothesizing that a hyperactive immune response may exacerbate Alzheimer's pathology. In our relentless pursuit of answers, we're also investigating the potential of neurogenesis. Can we stimulate the birth of new neurons in the adult brain to offset the loss caused by Alzheimer's? The promise of regenerative medicine looms tantalizingly within our grasp, yet remains just out of reach. As we navigate this complex landscape, we're also developing advanced diagnostic tools. Our aim? To detect Alzheimer's at its earliest stages when intervention might prove most effective. From biomarkers in cerebrospinal fluid to sophisticated neuroimaging techniques, we are creating a more precise roadmap to aid in our quest. But to truly conquer Alzheimer's, we must broaden our horizons. Our approach must be interdisciplinary, integrating insights from genetics, neurobiology, and psychosocial research. We must foster collaboration, bridging the gap between clinicians and researchers, between neurologists and geneticists, between patients and caregivers. In this quest, each discovery propels us forward. Each setback fuels our resolve. We are unraveling the tangled threads of Alzheimer's slowly but surely. We are learning, we are growing, we are adapting, and with each step we inch closer to our goal. As we venture deeper into the neural wilderness, the enigma of Alzheimer's continues to challenge, compel, and captivate us. It is a quest that demands our best, our brightest, our most daring. It is a quest that we undertake not just for ourselves, but for the countless lives touched by Alzheimer's. For in the end, our greatest triumph will be to turn despair into hope, to replace the darkness with light. Thanks for joining us on this deep dive into Alzheimer's. If these mind-blowing facts left you wanting more, smash that like button and subscribe to SciSips for more science in bite-sized bits. Let us know in the comments what questions you have about Alzheimer's research, and we'll keep you updated on the latest breakthroughs in the fight against this devastating disease.